Greetings. I have a little another little lathe video here. I'm gonna attempt to. You can sort of see this. So I got myself a new cross dial nut. So just to show you what kind of play I got, there we're at 0. There we're at, what is that? 68, 65, 67, I guess. So that's how much backlash I have in the mechanism here. It's better than 30 thou, probably about 35 thou. Got myself a new crossfeed nut. That came from Mike Neville at Jayhawk Machine Tool. So we're going to install this and see what we get. Now, mind you, this is the original, a little more light on the situation. This is the original lead screw back here. So it's not going to be 0, nor it wouldn't be 0 with all brand new parts, but we're going to see what we get on with the old lead screw and a new crossfeed nut. Because I've looked at this screw here. It's not brand new, obviously, but it's not that bad. And also, you figure this is steel. The nut's brass. I mean, this is a very close duplicate of the original. I mean, you can see where it's milled here. Drilled and tapped for the retaining screw right here. Got the hole through the middle for the oil. And rounded on the edge so it passes in the casting down here. So I'll go ahead and pop this guy out. To do that, I have to get this screw out, which comes out. There's a pin right here. Take this out. The screw will come out. And then I can drop the nut out, put the new one in, and we'll see what we get. Since I don't have enough hands to do that, I will have to kind of, improv it here. So bear with me, and we'll get this underway. Okay, so we got the cross pin out. This is the, your standard taper pin like you get on a lot of South Bend stuff. Well, this one, the small end is here, fat end is over here, so you drive it that direction. This is a taper attachment. Normally there would be a chip guard here, which is this guy right here. This has 2 screws that go into the casting here and here, and it has the locking handle that sits. Here's the binding handle if you actually want to use the taper attachment. So with the pin out, if things are nice and clean, and I've had this machine apart, so everything does slide pretty free, you can do is simply wind the handle and be careful you don't suck too much chips up in there. But you can wind the screw right on out of there, or at least quite a lot of the way. Alright, now I'm still turning the handle here, but we're not engaged anymore. So let me get the screw the rest of the way out of here. I'm going to have to pull this machine out from the wall because we're going to hit right here. And I will show you why that stopped. But it's a 2-piece screw that engages, the screw's back here, the handle's here, and eventually it will just slide out of the back. So let me get this out and I'll show you how that works. Okay, so I changed my mind here. I'm not going to pull this all the way out, mostly because I don't feel like re-leveling this. I can get this out just far enough. I mean, my finger just about fits between the end of this guy and the wall. But as you can see, this is the lead screw, or the crossfeed screw rather, and this is the keyway. Now, what the handle of this in is basically, if you can imagine, a piece of tube with a key in it that drives on this. And you can see how this is meant to slide, and that's to allow the function of the taper attachment to function. When you bind this to the cross feed here with the binding handle, this cross feed will slide in and out relative to this. So that is what makes all that work. It is as absolutely dead simple as you could possibly imagine. And there's our crossfeed retainer. I've already removed the little set screw. I think in stock form these had a flathead screw. I'm using socket key cap screws, just your standard wherever it went. Just a little set screw. It's 1032. So I'm going to take that out, and the crossfeed nut should drop out through the bottom, and I will fish that out. We'll have a look at it. Okay, so we got the nut out. This is the original. I don't know if you can tell here, but this is just a rough as cast part. It's got quite a lot of draft angle. You can see that, you know, they cast this and, you know, pulled it out of the mold like that. The surface here is just lathe turned. It's, you know, not perfect by any means, but, you know, it sits flat against the bottom of the casting here, which has a milled in pocket where the you know, this pulls up against. This here does come out. It threads into that. It just didn't happen to fall out, and there's no reason to really fish it out of there. May not be apparent, but the threads in there are very sharp. It's, you know, it's got a lot of miles on it. It's an old screw, or it's an old lathe with a lot of wear on it. So we're gonna put the new one in and see what we get. So just a little side by side here. You can see this is you know, a cast piece. It's tapered, where this is a milled piece. The sides are nice and parallel. The end here got a nice finish on it, but you can see where this is straight milled, and then this is done on a rotary table, I'm assuming. Drilled and tapped through the center, drilled and tapped through the center. Also drilled and tapped through the center, but if you notice, and I may not be able to get the angle on it, that is that size all the way through to here. So, I don't know, 5/16 or so, where that one, I'm going to guesstimate that's probably 1/8 of an inch down there. So the oil might actually retain in here just a little bit better and dribble out, you know, more as needed, where this one, you put a couple drops in, it just dumps through there and it goes away. So this may actually hold the lubrication better. So we'll put it in and see what we get. To get one of these guys in here, basically you just set it down here in the tray, you know, in the hole in the casting. You feed it back, then you push it up until you can get it to engage on the screw here. There's not a whole lot to it, but it requires more hands than I have available, so I'm not going to make a recording of that. Basically, you know, it's fairly self-evident once you get it into it. It's a nut. It sits up in here. You can kind of see my finger down there where it goes. So let me pop that in. We'll come back once I have this reassembled. Okay, so we are back together. I did have to tap the hole out here a little bit deeper. I just used a 3/8 course. Bottom tap, gave it an extra, I don't know, turn and a half, and now we're bottomed out. We weren't quite, this wasn't quite going down tight before, and it had some play in it. So as you can see, we're all together. Binding handle, dust cover. I've got the 2 screws in here, and let's see if we can get some visibility on the situation. Alright, so we're taking up the slack that way. We've got 10 thou of slack where we had about 35 thou before. So I'd say that's pretty good for an original 1957 crossfeed screw. It would probably be a little tighter if I had a new screw made, but, well, I'm sure that's a lot more money than that nut is. The nuts are currently on sale as of, well, it's October of 2016 for $30 shipped. I'm not sure what he's charging for a crossfeed screw, but it's probably more than $30, and I can live with 10 thou of 10 thou backlash. I'm not sure how tight it ever gets, but probably not a ton better than that. I'm not nearly good enough of a machinist to know, you know, to be able to notice the difference between 10 and, you know, what's a new one going to be, 3 or 4. So I don't think I'm good enough to justify that, but you know, that was a nice little improvement and didn't cost a whole lot of money. Anyway, if once again, if you happen to need one of these guys, Jayhawk Machine Tool, that's his eBay store. Mike Neville is the gentleman's name that makes these. See his email address, and I will put it in the thingamajig down the bottom. Thank you for watching. Have a fine day.